This metric is for evaluation, and this is to stat model is used to plot time series data. And you know what is time series data? Let's say temperature of maybe 1 month temperature. So that is a continuous data. Then you can download the data set from here, right? So I have added the link as well, and I created, see over here, you will find climate change. You can download different type of data set in Tanzania. This link is Tanzania. Download the data, and then you have different categories of data. Specialty aggregated data, raster file access, sea level data, API of data if you want to download through the code, terms of use, how to use data dictionary. So data dictionary is like what is the code and what does mean by this along with description, right? So that is just a sample. I don't know if Desmond have already shared with you or not. The only thing I did not add is the real data set because that you have to do by yourself. I am creating a random data set now because just for the practical purposes, right? For practice. So np random.seed 42 year np are range from 1980 to 2021. We can make it maybe, let's do it 2025, right? It is better. And we are using two columns like temperature and precipitation of that, and we are creating this from 1980, right? And then we have a data frame. Like after creating this data, we are converting it into year, average, and annual data set. So I will make this a separate column, sorry, cell, so that you would able to get this. So we have a random data set. We converted it into a CSV file. Then we are loading the data and pre-processing, right? I want to do these steps one by one so that you would able to see the data. So load the data will not do anything. Over here, I need to, okay. So we have load the data, and then you see it is like this one. If you want to see more column, you can see more column as well. So this command we use to load data, you already know that. So we created data frame df pd.read csv and name of the file, and then we are printing head with 18 values, zero starting from 0. And at second point, we see if there is any missing value in data. So we have data pre-processing. We are changing year to date and time. Data type, because it is needed, like year should be date and time. And then we are checking missing values. So there is no missing value, right? Because we have generated it. But when you will download dataset from here or from anywhere else, you might have some missing values. Okay, after that, we will do exploratory data analysis. And After exploratory data analysis, we perform line plot. So I will do all visualization from here. So we have, first of all, we need to check. I will put it separate because this one is separate. So we will see this descriptive statistic, like how many values are there. There are total 45 values. What are mean? What is mean? What is standard deviation? Minimum value, maximum value, and percentiles. We got it. After that, we will make a line plot and heat map and seasonal decomposition. So seasonal decomposition we got from this library. For line plot, you already know that. So we will have a figure size. Then where we want to make it data frame, and it index on year and column name, label, and color of that. We can make it green, made it red. We can make it green as well. Blue, you can make another one. Maybe you want to go with your own template. So you will plot on both of the columns, and what you want to keep title of the graphics, what will be the label on x-axis and y-axis. So x-axis, you know that, like label here, that is y-axis, and then title. You want to add legend here, like sometimes you see legend here, like for both columns, and grid if you want, and then show. So this is actually what it call the way how we plot visualization. The next one is heat map. Heat map we use for what we call it, for correlation and finding out, like visually it shows us how values are related to each other. And again, this is optional. If you don't want to write the size, you can skip this as well. And we use from SNS library like Seaborn. Name of the function is heat map. And as I have shared with you, we do it with correlation. If you want to add annotation, you can do it, or you can make it false. And this is color. You can add title. If you want to add something on x-axis, y-axis, you can add. And the last thing is, I will comment later on it later. Right. So we will first draw this. So see, we have blue line, this is green line, and why green line is, it should not be like that. Oh, okay, it is like this. So we have average temperature between these 2 days, and that is precipitation in millimeters, right? So you see the difference between values. So I think it's good if we make the plot separately. So I would like to make the plot separately so that we don't have merge values. So from here, I will remove this one, and so that I have just this graph better, the blue one. And from here, I will remove blue, so I have a better perception of green graph, right? So now we have a better graph representation of graphs. Then we have heat map. So this is heat map. So we have only two columns and they are one with each other. So temperature with visibility or precipitation is 0.27. If we have more columns for you, it would be the bigger one because this data set have more columns. Then we have seasonal decomposition data. So again, with season decompositional data, we have a plot based on different seasons. So you can see the trend, how it goes with the season, and this is actually for time series data. Okay, so now we got an idea of visualization of the data, how it was starting from 1980 until 2025. It's not 2022 because I changed it. This will also change to 2025 because I added more values. And yeah. So next step is machine learning. I will do one by one. So for machine learning, first of all, we will make the copy of the data. So we are making DFML machine learning and copy the whole data in that. And then we are making year as our index value, right? For example, when we are doing machine learning, let's say, so we need something, some target value. So let's say if we are saying marks and grade, right? So grade is index value or label because let's say if I have trained the data set, let's say there are marks 30, it means fail. And if marks are 35, it means pass, right? And maybe 70 is also pass. And later on, you will just add your marks. Let's say 78. So model will automatically predict the grade. So then on x-axis we have air and y-axis we have temperature, and then we have 1x and y temperature and y precipitation. Then we split our data 80-20 like train and test data. Then we will apply the model. So I always say application of model need just 4 lines of code. So you just split the data and you add the model. Since we already loaded this model here, linear regression, and now we will use this. And to use that, we need only, let's say, 4 lines of code. How to use that, I will show you. So we have We imported the library and we see linear regression and we give it to the variable. Variable could be anything. And then you fit this model on the data set. So we have linear regression model and we copied it into our LR model. So I can say maybe you can give it any name, model underscore one. This is name of your variable. Then you will fit this model underscore one. That is this whole function, or you can directly write this function as well. Dot fit, and you will fit on X train and Y temp train, right? And then you are predicting, based on this model, you are predicting model, like the same model underscore one, because that is name of my model, predict X test, predict the year. And so it will predict year. Similarly, this is first model application. If there are, let's say, thousands of model and complex to complex data set, you will always use these 4 lines of code. So you just need to assign variable to model, fit it, and predict it. That is the only 3 lines of code. Either you have complex to complex model, you have easiest model, you have complex data set, you have easier data set. So machine learning is always around these 4 lines of code. So this is model 1. We can evaluate it as well. So I would like to keep this as a separate. Okay. So then I will keep this as well as a separate. And then we will evaluate it. So I did this. I have created X and Y train models. I applied it. At moment, I cannot see anything because I'm not printing prediction. Then we'll go for evaluation. For evaluation, we have defined a function, right? So this is function, and we did function in our classes as well. So we created a function starting with def keyword. We know that name of the function, then parameter. So we are saying y true, y predicted, and model name. So what was the actual value and how it is predicted? Let's say in my data set, we were checking 76 is actual value. No, for 76, the actual prediction was pass and model predicted pass. Our actual value was pass and model predicted fail. So how is the prediction? So it will check from how it check that, because we already have a train data test data set, right? So this is, you see, I have X test and X train. So I apply model only on X train, not X test. So from X test, it will check whether prediction is true or not. Based on that, it evaluate the model, right? So we have actual value, predicted value, and name of model. And then we have square root, like mean square error. And we use it mean square error on actual value and predicted value. Then means absolute error, as we use it or square, y true and y predicted. Then we will print it model name evaluation. Let's say if model name is linear regression, it will use linear regression. If model is like other maybe model like related to we have the other model over here, random forestry or any other model, and then it will print mean square error and mean absolute error printed. Again, keep that in mind. This one is just this one is just function, right? Whenever we have to use call it, we need to call this. This is just function definition. It will not do anything, and we need to call that. So how we are calling here? I have added this code here. Evaluation. Evaluation of the model. YTEM test temp predicted, right? We have already created them here. And then we have name of the model, right? We will execute that. So it says mean square error is 29, absolute error is 0.27. The same process from here. Let's say I can keep it like a text so that you understand, would be able to understand it better. So the same process will be followed for random forestry. So I can tell you, see, name of variable, random forestry, model fit, model prediction, and for evaluation, evaluate model this, and then name of the model, right? Let's say if we want to make future prediction, how we can do that based on our results. So we will do it over here, future prediction. Future prediction year from, because we already have 2025, so we'll use 26 to 2030, and model name. So because it is random forest, so I need to execute this, and then I would be able to use that. If I don't use that, it will not work because it says the variable is not defined, right? So that's why I am defining here it here, and then using this is future prediction. And if I print that, you will see the values. These are the value for year 2026, year 2027, year 2028, year 2029. Most of the values are similar because we have used, we have generated the data. And the final thing is you can plot and visualize this. So we will see the size of the figure. We can plot index year and then future. This could be 2025 to 23rd, color whatever you want, and rest of the things are similar in this way. So this is the future prediction. And why is it like that? Because I have regenerated the data. If I go back, this was my actual result. You see? Okay, anyone have any question or query? All right. If not, would you be able to do by yourself with your own data until tomorrow? And then I will let you know how to make what it called how to make a Streamlit app. And on Sunday we can do it together and submit the project. Is it